Hello students, so here we are with the question third of the exercise 3.3 of the chapter pair of linear equations in two variables. So here the question third is form the pair of linear equations for the following problems and find their solution by substitution method. And the first question is the difference between the two numbers is 26 and one number is 3 times the other. Find them. So what have been asked in the problem is to find the value of the two numbers whose difference has been given is equal to 26 and the one number is 3 times the other. So we will first form the linear equation using this data being provided in the problem. So let here first number be x and other be y. Okay, that is here we are supposing that the first number value be equal to x variable and the other be equal to y variable. And here we are also assuming that x is greater than y, and this is our assumption. Just keep in mind. Okay. So according to the problem, what has been given is the difference between the two numbers is 26, means x minus y is equals to 26. Since x is greater than y, means x minus y is equals to 26. Suppose here we have assumed that y is greater than x, then what will be the linear equation in this case? Y minus x is equal to 26. But our assumption is x is greater than y, so the linear equation formed is x minus y is equal to 26. So this will be the first linear equation. And the second is the first number, or we can say the one number, is 3 times the other. So we can write it as x is equals to 3y. So this is our second linear equation. Now put second linear equation in first, or we can say substitute the value of the x in first linear equation. So here we will get 3y minus y is equals to 26. 2y is equals to 26 and y comes out to be equal to 13. Let this be third. Now substituting this value of y in second, that is put 3 in second. So now x comes out to be equal to 3 into 13, which is equal to 39. So from here the first number, that is x value, is equals to 39, and the second number, which is y, its value comes out to be equal to 13. So this was all about the problem first of the question third of this exercise. So now coming to the second problem of third question. So the second problem is the larger of the two supplementary angles exceed the smaller by 18 degrees. Find them. So in order to find the two angles, we will assume that if x and y are supplementary angles. Okay. And as we know, if x and y are the supplementary angle, then their sum will definitely be equal to 180 degree. That is, here we are assuming in this question y is greater than x. Just remember, this is an assumption we are taking. Okay. And what is the second condition being given in the problem? The larger of the two supplementary angles exceed the smaller by 18 degree, and as we have assumed that the y angle is greater than x, so here it will be y minus x is equals to 18 degree. So here first we will find the value of y. Y comes out to be equal to 180. Let this be equation first, second, and this y will be equal to 180 minus x, and let this be equation third. Now substitute the value of the y in second equation, that is put 3 in second. So here it will be 180 minus x comes out to be equal to 18, or minus 2x is equals to minus 162, where x value is equals to 81 degree. Means x angle is equals to 81 degree. So in order to find the value of the y, that is y angle, we will substitute this value of x in third equation. Now put fourth in third. So putting this value of x in third equation, y will be equal to 180 minus 81, which comes out to be equal to 99 degree. Right. So the two angles are y is equals to 99 degree and the smaller angle, that is x, is equals to 81 degree. So this was about the problem second. Now coming to the third problem. What the third problem says, that the coach of the cricket team buys 7 bats in 6 balls for rupees 38,000. Right. And also it's been given that later she buys 3 bats and 5 balls for rupees 1,750. Find the cost of each bat and each ball. So in order to find the cost of each bat and each ball, we will let each bat cost is equals to rupees x, and each ball cost is equals to rupees y. Okay. Now according to the problem given, it's been given that the coach of the cricket team buys 7 bats and 6 balls for rupees 3,800. Means 7x plus 6y is equals to 3,800. So this will be the first equation, and the second equation can be formed from she buys 3 bats and 5 balls for rupees 1,750. Means 3x plus 5y comes out to be equal to 1,750. Now the first step is to find the value of y. So from the first equation, the value of the y comes out to be equal to 3,800 minus 7x by y. Let this be equation third. Now put 3 in second equation, that is substitute the value of the y in second equation. So here we will obtain 3x plus 5, putting the value of y is equals to 1,750. Okay. In solving this, that is finding the LCM, so what here it will be 18x plus 19,000 minus 35x is equals to 1,500, or x value comes out to be equal to 500 on doing the mathematical calculations. Now put this value of x in third equation, that is substitute the value of x in third equation. So y comes out to be equal to 38,000 minus 3,500 divided by 6, right? So 3,800 minus 3,500 comes out to be equal to 300 divided by 6, where y comes out to be equal to 50. Means the value of each bat cost is rupees 500 and the cost of each ball is rupees 50. Okay, so this was about the problem 3rd of question 3rd. Now the 4th problem is the taxi charges in a city consist of a fixed charge together with a charge for the distance covered. For a distance of 10 km, the charge paid is rupees 105. And for a journey of 15 km, the charge paid is rupees 155. What are the fixed charges and the charge per kilometer? How much does a person have to pay for traveling a distance of 25 km? So in this problem, the fixed charges and the charge per kilometer has been asked. So for this question, let fixed charge be rupees X and per kilometer charge be rupees Y. Okay, so as per the data being given in the problem, what it's been given that for the distance of 10 km, the charge paid is rupees 105 and for a journey of 15 km, the charge paid is rupees 155. So the two equations which will be formed will be x plus 10y is equals to 105. Let this be first equation, and the second equation will be x plus 15y is equals to 155. So we have obtained two linear equations from this problem. Now in order to find the value of the variables x and y, we need to use the substitution method. So from the first equation, we will find the value of x, which comes out to be equal to 105 minus 10y. Let this be equation 3rd. Now substitute this value of x in second equation. Substituting it, 105 minus 10y plus 15y is equals to 155, or 5y is equals to 50, where y value comes out to be equal to 10. Let this be equation 4th. Now put 4th in 3rd. That is, substitute the value of y in 3rd equation. Substituting it, x comes out to be equal to 105 minus 10 into 10, or 105 minus 100, which is equals to 5. Therefore, what it says that hence fixed charge is equals to rupees 5, that is x, and charge per kilometer, which was equal to y, comes out to be equal to rupees 10. Right, and also there has been asked that how much does a person have to pay for traveling a distance of 25 km. So the charge for 25 km will be equal to x plus 25y. Right, means charge plus into kilometer into the charge per kilometer. Substituting the value of x and y respectively, it's 5 plus 25 into 10 is equals to 5 plus 250, which comes out to be equal to rupees 255. So this was about the problem 4th, that is the charge comes out to be equal to rupees 5 and the charge per kilometer comes out to be equal to rupees 10, and the charge which a person have to pay for traveling a distance of 25 km is equals to rupees 255. Now the 5th problem is a fraction becomes 9 by 11 if 2 is added to both the numerator and the denominator. If 3 is added to both the numerator and the denominator, it becomes 5 by 6. Find the fraction. So in order to solve this question, let fraction be x divided by y. That is, x in the numerator and y is in the denominator. According to the information given in the problem, what it says that a fraction becomes 9 by 11 if 2 is added to both the numerator and the denominator. So now we will be adding 2 to both the numerator and the denominator, which will be equal to 9 by 11. Let this be first linear equation. And also it's been given that if 3 is added to both the numerator and the denominator, it becomes 5 by 6. Means x plus 3 divided by y plus 3 is equals to 5 by 6. This be the second linear equation. Okay. Now solving the first linear equation, that is 11x plus 22, and taking this to the right hand side, that is denominator to, from the left hand side to the right hand side, we will get 9y plus 18, or we can say 11x minus 9y is equals to minus 4. Let this be fourth equation. And also simplifying this, it will be 6x plus 18 is equals to 5y plus 15, or we can write it as 6x minus 5y is equals to minus 3. Let this be this will be the third linear equation. We can take anything, but according to the sequence it will be first, second, so we will write this as, in order to avoid any confusion, we will write this equation as third linear equation and this be the fourth linear equation. Okay, now from equation first, or we can say from the equation third, which is a simplified form of the equation first, the value of x comes out to be equal to minus 4 plus 9y divided by 11. So let this equation be fifth equation. Now substitute this value of x in the fourth linear equation. So substituting it, x, it's minus 4 plus 9y divided by 11. Then minus 5y is equals to minus 3. Or solving it, what we will get is minus 24 plus 54y minus 55y is equals to minus 33. So solving it, the value of the y comes out to be equal to 9. Now substitute this value of y in fifth. That is, put 6th in 5th. Substituting this value, the x comes out to be equal to minus 4 plus 9 into 9 divided by 11, which is equal to minus 4 plus 81 divided by 11. Right? And solving it, the value of the x comes out to be equal to 7. Means for this problem, x comma y is equals to 7 comma 9, or we can write it in the fraction form as x by y, which is equal to 7 divided by 9. So this was about the problem fifth. Now coming to the sixth problem of this question, here the sixth problem says 5 years hence the age of Jacob will be 3 times that of his son. 5 years ago, Jacob's age was 7 times that of his son. What was their present ages? So in the question, it's been asked to find the present ages of Jacob and Jacob's son, and the comparison have been given in statement 1 and statement 2 with respect to the present age. So in this question, we will let age of Jacob be x and age of his son be y. Okay. Now, according to the information being given in the problem, x plus 5 is equals to 3 into y plus 5. As it's been given that say 5 years hence, means 5 years from the present age, the age of the Jacob will be 3 times that of his son. So in mathematical form, it will be x plus 5 is equals to 3 into y plus 5. Right, let this be first equation. And also it's been given that 7 years ago, Jacob's age was 7 times that of his son. So the mathematical expression will be x minus 5 will be equal to 7 into y minus 5. Let this be equation second. Okay. So now simplifying it, x comes out to be equal to 10 plus 3y. Let this be equation third. And from here, x minus 7y is equals to minus 30. Let this be equation fourth. Now substitute this value of x, that is put third in fourth linear equation. Substituting the value of the x in fourth linear equation, it comes out to be equal to 10 plus 3y minus 7y is equals to minus 30. Or minus 4y is equals to minus 30 minus 10, which is equals to minus 40. And the y comes out to be equal to 10. Now substituting this value of y in fourth linear equation, instead substitute it in third linear equation. So put 5 in third in order to get the value of x. So here x will be equal to 10 plus 3 into 10, which is equal to 10 plus 30. Means x is equals to 30. So from here 30 plus 10 is equals to 40. From here the Jacob's age comes out to be 40 years and Jacob's son age comes out to be equal to 10 years. So the conclusion is present age of Jacob is equals to 40 years and present age of Jacob's son is equals to 10 years. So this was all about the problem 6 of the third question of exercise 3.3. I hope this question is clear to all of you.